Hey everyone, and welcome to this explainer. Today, we're unpacking a fascinating and honestly deeply counterintuitive piece of research from Sentient Labs. We usually just assume that if you teach an artificial intelligence agent a new skill, it automatically becomes smarter, more capable, and just generally better at its job, right? But what if making an AI agent smarter actually breaks it? That is exactly the paradox we're going to explore today.
So let's just dive right in. We are looking at a huge fundamental question in AI development right now. Do smarter AI agents actually make more mistakes? Developers are spending a massive amount of time loading up AI models with new procedural skills, like, giving them instructions on how to navigate a massive spreadsheet or how to parse some complex financial document. But this research asks a really critical question. Is adding all these new skills to an AI actually a double-edged sword? Does teaching a model something brand new cause it to just forget how to do something it already knew perfectly well?
Well, listen to this stat, 59%. Across nearly 6,000 paired runs testing AI agents, both with and without new skills, researchers found that 59% of the gross gains made by adding skills were completely canceled out by brand new errors. Let that sink in for a second. For every step forward the AI takes by learning a new skill, it takes more than half a step back because it suddenly fails at tasks it used to complete with zero issues.
And that brings us to what the researchers have coined the regression tax. This is the hidden cost of adding context and skills to an AI. A regression happens when a task that was successfully solved by a bare AI, meaning an agent without any extra skills, is suddenly failed right after new skills are added. It's kind of like teaching an expert mathematician a brand new way to multiply, and suddenly they literally forget how to add. This tax is a massive, often invisible drain on AI reliability.
And honestly, this perfectly highlights where the tech industry is going wrong and how it measures success. The industry standard right now is to just look at average improvement. They see the total pass rate go up, and everyone celebrates. But that metric completely hides the cost. The researchers argue we absolutely must look at the net effect, which is the gross gains minus the regressions. Because think about it, two different skill libraries might show the exact same average improvement, but one might be getting there by breaking dozens of perfectly good tasks just to learn a few new ones.
If we break down the hard numbers across those thousands of runs on office automation benchmarks, adding skills yielded 553 gross gains. So the AI learned to solve 553 new tasks. Great, right? But then there were 324 regressions. That means 324 original successes were just wiped out. The final net effect? Only 229 tasks. Evaluating AI solely by its gross gains misses a massive chunk of the story, completely ignoring this regression tax.
So to diagnose exactly why this tax is happening, we really need to understand how an AI agent actually thinks. You can break a task down into three main stages. First, you have grounding, which is just reading the right inputs. Next is the method or reasoning, that's the actual procedure or calculation. And finally, verification, where it checks the output before finalizing it. Keep this mental map in your head, because we're about to see exactly which of these stages just completely break down when new skills are added. By carefully analyzing the execution traces, basically the step-by-step logs of how the AI performed the tasks, the researchers identified three distinct and honestly fascinating mechanisms that cause these regressions. Number 1, skill description osmosis. Number 2, grounding displacement. And number 3, verification displacement. We're going to walk through each of these one by one because they fundamentally change how we should be thinking about AI context.
Mechanism 1, skill description osmosis.
Now, this is arguably the most mind-bending cause of AI regressions discovered in this research, mostly because it involves the AI making a mistake based on a skill it didn't even use. A skill can change an agent's behavior simply by being present in its context window, even if the agent never actually invokes or uses that skill's code. When you give an AI a skill, the description of that skill just sits there in the system prompt constantly. It's like trying to take a math test while someone is whispering a recipe for soup in your ear. The mere presence of those words can completely derail the AI's reasoning.
There's a perfect anecdote from the data to illustrate this. It was task UID 0096, where the AI was asked to calculate a customs duty rate. Without any extra skills, it got the answer exactly right, around 37.7%. Then, a skill library was loaded in. Now, the AI never actually triggered or used any of those new skills. But simply because the words revised and customs were sitting in the background description of an unused skill, the AI shifted its answer to a completely wrong 38.7%. The distracting thought literally infected its perfectly good baseline logic. Wild, right?
Mechanism 2,
Grounding displacement. So, if osmosis happens when a skill isn't used, grounding displacement happens when a skill is used. But it strikes at the very first stage of that pipeline we talked about earlier, the input stage. This happens when a new procedural skill overrides the AI's natural ability to read its inputs correctly. For instance, in one public works spending task, the baseline AI correctly read the starting figure as 549, did the math perfectly, and got the right answer. But when a new navigation skill was added, the AI actually invoked it. Its math was still perfect, but the new skill forced it to navigate to the wrong table, causing it to read the starting figure as 949 instead. The new procedure completely displaced the correct grounding.
Mechanism 3. Verification displacement.
Okay, so if grounding displacement breaks the task right at the beginning, verification displacement breaks it at the exact opposite end, just before the AI delivers its final answer. The crucial point here is that adding procedural skills can, ironically, make the AI overconfident. The new procedure can actually suppress the natural double checks the agent would normally perform on its own work. The AI's internal logic is perfectly intact, the formula it wrote is completely sound, but it just fails to execute a final check to verify if the output is formatted correctly or holds the right sign.
To see just how impactful this missing verification step is, we can dive into the data from the spreadsheet bench tasks. Out of hundreds of failing tasks that involved writing a spreadsheet formula, only 60% were actually wrong. A massive 34% of these so-called failures were actually perfectly good, correct formulas. The AI had done all the hard work right. It just lacked the proper verification check to actually evaluate the formula and output the final value, which caused the automatic grader to mark it as a total failure. And to prove this, the researchers stepped in and applied a concrete, execution-based check. Basically, they just ran the spreadsheet formulas through a full engine to see what they actually produced. And by doing this, they instantly recovered 226 of these failed outputs. 226 tasks flipped from failures to successes just by fixing that final verification stage. When we revisit our pipeline diagnosis, it reveals the overarching problem with how we're building AI skills today. Developers are just absolutely obsessed with that middle stage, the method, the reasoning, the procedure. They pump the AI full of procedural skills. But in doing so, they are vastly overserving the middle while completely neglecting and even accidentally sabotaging the critical ends of the pipeline. I'm talking about the grounding, where data is inputted, and the verification, where it's checked.
And hey, if you need more proof that the ends of the pipeline are the real bottleneck, just consider residual failures. These are tasks that the AI fails at both without skills and with skills. No matter what procedural skills you add, these tasks stay broken. Why? Because the execution traces show that these unsolvable errors concentrate entirely at the exact same neglected input and output stages. You simply can't fix a grounding error with a better math procedure.
The cure: fixing the regression tax.
All right, we've diagnosed the disease. So how do we fix this regression tax? The researchers lay out 4 really clear prescriptions. First, we have to stop looking at average improvement. We should always evaluate the net effect by specifically pairing gains against regressions. Second, because of that osmosis issue, you absolutely must test skill descriptions in the context window completely separately from testing the execution of the skill itself. Third, instead of giving AI generic procedural routines, supply specific grounding information so it reads the data right the first time. And finally, strengthen those executable output checks to catch those perfectly good answers before they get tossed out as failures.
Which leaves us with a final, provocative thought to take away from this explainer today. As we rush to give AI agents more tools, more context, and far more complex procedures, we really have to ask ourselves, are we actually building AI that is truly smarter and more reliable? Or, by ignoring the regression tax, are we simply building AI that is just differently flawed? Understanding this balance is going to be absolutely crucial for unlocking the next true leap in artificial intelligence.